Welcome. Today we'll be discussing section 3.2, law of sine, angle side angle, angle side problems, as well as side angle problems. So remember, we're going to reference a triangle as such, where alpha is tied to the opposite side A, beta is the angle for side B, and gamma is the angle for side C. When we have law of sine, we're simply going to have A divided by sine of alpha is equal to B divided by sine beta is equal to C divided by sine of gamma. So the pairings we can divide when we have the sine of the angle. And because we have side lengths that are positive, we can take the reciprocal of all of these. So if I take the reciprocal of one, I take the reciprocal of all the other equations. And I have another set of identities. Now, two things to note from here is that we'll use these for angle side angle and angle side questions. We will also have the property if side 1 is greater than side 2, then angle of side 1 is greater than angle of side 2. I wrote it in this context because it's any such side. As long as A is greater than B, then we know that alpha must be greater than beta. And that is true for any such side. So use that to check your work. For example example 1, we now have A equaling 10 centimeters, beta equaling 52 degrees, and gamma equaling 34 degrees. So when I solve for this triangle, an easy one to get is alpha is equal to 180 degrees minus 52 degrees minus 34 degrees, because that is just beta and gamma, which gets us 94 degrees is equal to alpha. So if you're very visual, I highly suggest you to write down a triangle. And sometimes there'll be a proportion, sometimes it won't be a proportion. Just be forgiving on yourself. So here, I'm going to call this 94 degrees. This is 52 degrees, 34 degrees, and we have 10 centimeters. And we have B and C that we don't know. So we want to find those. So now I can just match up. All right, here's B and this is beta. So I'm going to have B over sine of 52 degrees is equal to 10 over sine of 94 degrees times by sine of 52. And I'm going to have B is equal to 10 times sine of 52 degrees all over sine of 94 degrees. And that gets me B is approximately equal to 7.9 centimeters. So now, when I solve for the rest, we can find C. I can just do another law of sine. If you wanted to, you could use law of cosine here, but it's easy to do law of sine. So we have C over sine of gamma. What's gamma? 34 degrees is equal to. Now, I highly suggest that you stick with using A. Now, why is that? Is because, sure, we found 94 degrees, but 94 degrees is exact, where if we use B, we might have an exact angle, but we don't have an exact side length. So in order to not compound error, we should use A and alpha again. So now when we plug this in, we then have C is equal to 10 sine of 34 degrees divided by sine of 94 degrees, which then C is equal to 5.6 centimeters, or it's approximately equal to. So now, as a quick check, we can go 10 is larger than B, larger than C, and so we should expect to see alpha being larger than beta and larger than gamma. Yes, it is. So that's good. B is larger than C, so we should expect that beta is greater than gamma, and yes, that is true. So we are fairly confident that these are solutions. If we want to be even more confident, plug this into law of cosines, and it should all work out with small margin of error. So now what's good about the side angle side, so that's what this one was, because we had a angle side angle, is that, because these were the givens, the ones I circled, is that it made it very rigid to where we only had one solution. That is not always going to be the case. So when we have a theta equaling sine inverse of some number x, we could also have it be a negative value. That doesn't make sense in terms of a triangle because we have geometric angles which are inherently positive. And so how we can accommodate this is that if the angle is less than 0, then theta nu, so just like another one that we should use, is 180 degrees minus our old one. So sine inverse of x. That is what we should use. And if we have one that is, if we have like an x that is like negative or like -2 or +2 or +3, something greater than 1, then of course we have no solution to that. Why do we bring this up? Well, because of when we talk about side angle, but we do have an issue when we have angle side. So let's, or sorry, the issue is when we have these last classifications of side angle. When we have angle side angle or angle side, it again will be a very rigid question and we'll get one solution. But let's look at side angle questions or cases. So we could have a no solution. Could be one solution. And it could be two solutions. And so the reason behind that is we're given a side, and an angle. So I don't know where to place this. I also don't know how far this is. So if we draw it as such, I could imagine that I could take this and swing this across. And notice I never touched this length here. It didn't matter how big I would have this length either. I never got to touch it. I never formed a triangle. Conversely, if I had this be here and I brought it down, we could have it be something like there. But we could also swing it around and we might touch here. And I have the same length there. I might have it go outside where I don't have another point out here. I can't form another triangle. So I have these different cases to worry about of where I could have one solution and the other solution is thrown out. I could land perfectly and just touch it once. Or I might not be able to reach the bottom or the base of the triangle at all and have no solution. So how can we find out these different classifications? Well, we want to first write the values in order. So again, side, angle is what we're given. We want to draw a picture. And then if x is greater than 1, then we have no solution. Where x is the value inside the arc sign. So theta equals arc sine of x. So I'm talking about that x. If it's greater than 1, no solution. If not, we have theta 1 is equal to sine inverse of x, and theta 2 equal to sine inverse of x. We're going to take a negative and add pi, or 180 degrees. So pi minus sine inverse of x. In other words, theta nu. We're going to have both of them because both of them are a possibility. And if my theta is negative, well then I just have one possible value. And I have to check and make sure that all works. So once we have both of our thetas, we're going to evaluate them. What does this look like? Well, looks something like lost my place in my notes. Do this one. Yeah. So here is example 2. So we have A is equal to 10 feet. B is equal to 8 feet. And we have beta is equal to 40 degrees. So when we write this, we have 10, 8, and so if this is 8 feet, this is B, this means our beta is over here, which is equal to 40 degrees. And our alpha, well, we could write this in any which way. So we could write this being our alpha, but how I kind of drew it, I'm going to write, or A is going to be here. at 10 feet. So I drew it. If I mirrored this, I would then have a proper side angle. But in this case, I have an angle side. Doesn't really matter. Just that the acronym spells a bad word. So now from here, I arbitrarily drew this. I don't know where this is. It could reach, it could not reach. I'm purposely drawing it open because I want to know of where this sort of attaches to the triangle, if it attaches at all. So we can use law of sine. So we're going to start with 8 being b divided by sine of 40 degrees is equal to a, which is 10, divided by sine of alpha. We're going to solve for sine alpha, so times this to the other side, divide, and then take inverse sine. So we're going to have alpha is equal to sine inverse of 10 divided by 8 times sine of 40 degrees. Now, when I evaluate this, I'm going to get alpha to equal 53.47 degrees. Now, I skipped a step here that I'm going to showcase because sometimes what can happen if we're not careful and we just go through like this, we're going to get a value and we're going to go a million miles an hour, and then all of a sudden we're going to run into an issue and we're going to be like, hey, what happened? So an important step to do here is to actually find out what this inside is. So we have to verify that it is less than 1. That's within 1 and -1. Well, it should always be positive, but or for the most part. So what we can do here is get 10/8 sine of 40 degrees, and that is approximately equal to 0.8035. So that's our little check. And we can have alpha, and we're going to call that alpha 1. Because then we can generate an alpha 2 and have that be equal to 180 minus alpha, which then we get 126.53 degrees. So why is this important? Is because this triangle, it could attach to somewhere out here, or it could attach to somewhere down here. I don't know. I just drew this kind of open-ended for that purpose. So we're first going to say, well, what if alpha 1 equals 53.47 degrees? What if we have that? Well, we then know that gamma must equal 180 degrees minus alpha 1 minus beta, which equals 86.53 degrees. And now we can use law of sine again, and we can have C over sine of gamma is equal to, we're going to have, let's use B. So we're going to have 8 divided by sine of 40 degrees times by sine of gamma to the other side. So we're going to have sine of gamma here. Plug that in and we get C is approximately equal to 12.42 feet. And that is when alpha is, that's when I have alpha 1. So I'm going to include that here. Alpha 1 is equal to 53.47 degrees. Now, if alpha 2 is equal to 126.53 degrees, I'm going to do the exact same thing. C divided by sine of, oh, nope. First we want to find gamma. So we have gamma equal to 180 degrees minus alpha 2 minus beta, which gets us 13.47 degrees. And then we're going to have C divided by, or we're going to have the exact same source. C equals B times sine of gamma divided by sine of beta, which is 40 degrees. Plug in B, which is 8, plug in alpha, or sorry, gamma, which is 13.47. And we'll have C being approximately equal to 2.90 feet. And we can include that alpha 2 is equal to 126.53 degrees. So again, we can take this, go through, and write down that that this triangle could happen in either case. Because of this angle, we could imagine that if I drew this a little bit more proportionately, we could have a very long angle, a very big angle here, which then, so this is 8, and it forms like a very large angle. That is one possibility for this, having this be 10, this be 8, and very large angle here, and a very narrow angle here. Or we could also see this if it was to form something like this, and we stretch this out, we'll have a less steep angle, and we almost have like an isosceles triangle that this would make. But essentially, we have two different triangles that could be made up of these restrictions, and we have to account for both of them. This is going to happen for side-side angle cases. And that's why we're going to have a lot of them. A lot of different examples. So for another example, we can do A is equal to 10, B is equal to 8, and this time we're going to have beta is equal to 100 degrees. So when we go through this, we can do something a little bit more interesting and go, all right, we have an obtuse angle, something greater than 90 degrees. So that would mean that beta would have, that B would have to be the largest side because beta is way too big to have another obtuse angle. So since A is 10, so since A equals 10, which is greater than 8, which is equal to B, then alpha must be greater than beta. However, beta equals 100 degrees. So alpha must be less than 80 degrees, which is a contradiction. So no solution. This will be your check on learning for this video, is to write down this answer in whatever context that makes the most sense to you, is that this is a no solution of a triangle, and that this is an important thing to check on any side angle question. So continuing on, we have another example. This time we have A is equal to 7, B is equal to 10, and beta is equal to 40 degrees. So I'm going to draw my triangle. So I have 10, 7, and 40 degrees. So I'm going to write this 40 degrees more like that. So 40 degrees. This is our beta. Here's our B, which is equal to 10. Here's our A, which is equal to 7. So we're going to have some C value here, and maybe these connect, maybe they don't. I don't know. I'm just drawing it sort of like this. So I have my side angle. All right. Well, we should expect that alpha would be less than beta because A is smaller than B. So let's plug this in to our sines. And so we're going to have B over sine beta is equal to A over sine alpha. Solve for sine alpha, and we get sine alpha is equal to 7 divided by 10 times sine of 40 degrees. This is approximately equal to 0.47. So it's less than 1, so we're good. And we can proceed, and we find that alpha is equal to sine inverse of 0.47. Ideally, plug this into the calculator, not the approximation. And, or actually, yeah, this is 4.5, my bad. Which then this is equal to about 26.74 degrees. Now that's alpha 1. Alpha 2 is equal to, and we're going to take 180 minus this. So 180 degrees minus alpha 1, which is 153.26 degrees. So what happens is we can look at this and say, hey, that is much larger than 40 degrees. Alpha 2 is. And alpha is not larger than beta. So we can just cross this off. That's too large. So we're going to proceed with this and see if it works with all that. So we know that alpha 2 is not possible. So alpha 1 is equal to alpha, which is 26.74 degrees. So then we have gamma equaling 180 degrees minus alpha minus beta, which when we plug them in and solve, we get 113.26 degrees. So this is clearly the largest angle, so we should be expecting the largest side. C divided by sine of gamma, or gamma, is equal to, and we're going to use B over sine of beta. We're going to solve, so times by sine of gamma to the other side, so we have sine of gamma, plug it all in, and we have 10 times sine of 113.26 degrees divided by sine of 40 degrees, which then C is approximately equal to 14.26 units. And don't forget to highlight gamma as well. And there's our answer. So in summary, when you have any other orientation besides side angle, you're going to get one solution. It's because of the side angle and with the property of sine is that we can all of a sudden have to account for multiple solutions to be valid or no solutions. And we can't connect the triangle at all. So I highly suggest you to write down your picture like this whenever you do a side angle, because we can't guarantee it being a triangle. We might not have a triangle, and this is a passive way of reminding you of that. Anyways, thank you for watching and have a great day.